So a scale factor is how much bigger or smaller something is. Okay. Now, the scale factor determines whether the dilation is an enlargement or a reduction. Okay. Yesterday, right before we ended, we talked about how dilations in another context are like or in a pupil, right? When the pupil gets smaller or bigger, right? That's dilating the shape. Okay. So when we talk about a dilation here, we're talking about enlargements or reductions. So if you made your smaller tree the image, so it has prime markings on it, then what you've displayed is a reduction. Okay. How many of you made your prime figure the smaller tree? Okay, so most of you have a reduction. How many of you made your prime figure the bigger tree? Okay, so in your cases, your dilation would be an enlargement, right? It's getting bigger. Okay. Now, a key thing with dilations in general is that these will always create similar figures. Can anybody define for me like two figures that are similar? What do I mean by that? Yeah. Same exact shape, but different sizes, right? So if there's angles, they're the same. If there are the side lengths, they're proportionate, right? For example, all circles are similar, right? By definition, all circles are the exact same shape, but different sizes. Okay? So, all right. So a couple of things that we should write down someplace. Okay? And you can do it on your graph paper or any place else if you want to. Okay? A dilation might look something like this. Okay? We have our triangle. Okay, right here. Okay? This is our center of dilation. Okay? This distance from C to R and this distance from C to R prime, right, are how we can help determine our scale factor, which we'll get into in a moment. Okay? All right, but this is something that we might look at for a dilation in space, not on a coordinate plane. Okay? One thing I want to make sure is clear, and we've said it already, is that dilations preserve angle measurement, which means that the shape is not going to change, right? So if we have a square, it still will be a square after it's been dilated. Okay, so in this class, you'll be asked to perform dilations on geometric figures. If what you start with and what you end with is not the same shape, then you've done something wrong. Okay, we need to be starting and ending with the same shape. Okay, scale factor. So this is the part that I need you to make sure you write down, because this is our first actual calculations that we're going to have to do. Okay, the scale factor of a dilation is the ratio of a length of the image to the corresponding length in the pre-image. Okay, with the length of the image always on top or in the numerator. Okay, for this figure shown above, if we wanted to find the scale factor, we would do C to R prime divided by C to R. Okay, I'm going to write this a little bit bigger for you. Okay, or we could do P prime to Q prime divided by P to Q. Okay, or we could even do P prime to R prime divided by P to R. Okay, the key thing with this and what you really need to take away from this is that scale factor is always image over pre-image. Okay, image over pre-image. So you're always going to take your resulting figure, whatever the lengths are associated with that, and divide it by your original figure, whatever the lengths are associated with that. Okay? You have to make sure they're corresponding. So for example, I wouldn't take this length and divide it by this length. Right? That doesn't make very much sense. It's not going to tell us anything. Okay? So scale factor. Now scale factors will determine what type of dilation we have. Okay? They'll determine if our dilation is an enlargement or a reduction. Based on intuition, who has an idea of what type of numbers will represent an enlargement? What's that? Whole numbers. Okay, what about 1.5? Still a dilation, or still an enlargement, right? So, not just whole numbers, but what else? Bigger than 1, right? Anything bigger than 1 will be an enlargement. Okay, and I think I might actually have this on the screen. Okay, we'll put it right here. Okay, so if the scale factor is greater than 1, that's an enlargement. If the scale factor is less than 1, that's a reduction. Okay, again, that should be fairly intuitive, but you want to make sure we spell it out. Yeah. So that's a good question. There's no such thing as a negative scale factor, right? Because we're always talking about distance or scalar numbers, then we aren't going to get negative. Then it'd become like inverted on itself, and it'd be some sort of like inception sort of stuff going on. So, okay. So always positive numbers, bigger than 1, less than 1. Okay. If it's equal to 1, then I don't know why we did it, right? That's not really a dilation. It's just saying it's the same. Okay. All right, so there's some basics with dilation. What I want you guys to do real quick before we do this next part is on your paper, you have a part 3. I want you to do this with your group, okay? But we don't have a great amount of time. So we're going to say like 4 to 5 minutes to finish through part 3. So if you need to divide and conquer the work, then do that, right? But be effective in your time management, 4 or 5 minutes for part 3, okay? On that coordinate grid, you had a triangle to create. It told you to dilate it by a certain factor. What was the factor it told you to dilate by? Also by 2. Okay. How did we decide where our new points would be there? Because most of you didn't have rulers yet. So how did we decide where our new points would be when we had that dilation? Yeah, Miriam. Okay, so you kind of almost used a slope a little bit and then doubled. So whatever you did to get to the first point, you did it again. Did you repeat that with all 3 points? Okay. Did anybody else do it differently? Yeah. So you multiply the coordinates themselves by 2. So one of the points is 1, 2, right? So you multiplied it by 2 and you got 2, 4. Or no, I guess I have it backwards. 4, 2. Okay. Anybody else do it that way? Okay, what I'm trying to get at here a little bit with both the front and the back is that scaling something in mathematics, what does it mean mathematically? It means to multiply, okay? You'll get to this point in math where we talk about things called scalar multipliers, right? And usually in a calculus class someplace, we'll talk about scalar, okay? It really just means to multiply things, okay? So whenever we do a scale factor, we are multiplying. If you remember that little fact, you will always be able to perform a dilation because you're just going to multiply by the scale factor. That's all that you're going to do. Okay? If it's in a coordinate plane, it's easy. You're just multiplying coordinates by the scale factor. If it's not in a coordinate plane, like the back of the page, then you are multiplying distances by the scale factor. Okay? But the big thing is that you are multiplying. Okay? All right. Now, in this, for example, we have an example of an enlargement. This is our original figure, the A, B, C, D right here. A prime, B prime, C prime, D prime is twice as big. Okay, where is its center of dilation, by the way? Remind me your name? Yeah. Harrison. Where's the center of dilation? A, right here, right? Okay, because that's the point that stayed the same. It's the point that didn't move, right? Okay, somebody else tell me where's the center of dilation in this reduction? C, right? Because everything shrunk to it. Okay, so however you can help yourself remember what the center of dilation is, right? Typically it's the point that doesn't move. So if everything else moves and it doesn't, then that's the center of dilation. Okay. Now, one thing too, just to get in our heads about the scale factor, we could figure out scale factor. What was the formula for scale factor? Can anybody remind me? What was our formula for scale factor? Image over pre-image, okay? So image over pre-image. So in this one, image was 4, because the side length here is 4. Pre-image is 2, so I get a scale factor of 2, right? Image over pre-image, okay? If I do the same thing over here, image is 2, pre-image is 8. So 2 over 8 gives me 1/4, right? Just to make sure that we're on the same page about how we're finding this, okay? What I find typically happens on this quiz, when we take this quiz, is that if you're messing up the scale factor, it's because you're reversing the order, okay? So image over pre-image, new figure over old figure, and that's usually how you're going to come up with it, okay? Here's what I want you to do. In your groups real quick, look at this picture, and I want you to determine the scale factor of that picture. I don't care how you do it. I'm going to give you about 30 seconds or so to do it in your groups. Okay? Ready, go. students. Um, so, table 6, what did you guys come up with for the scale factor? Okay, 1/3. How'd you come up with 1/3, Sydney? So that's 3. Okay, so image over pre-image, you did 1/3, and that gave you that. Okay, did anybody else use a different side or anything like that to find this? Everybody used BC? All right. Okay. I probably would have used CD just because that would have jumped off the page to me a little bit, but that same process would have worked, right? Because I have a side of 6, a side of 2, right? 2, 6 equals 1/3, so we get to the same spot, right? Okay, but as long as we can find that, we can use side lengths. Did anybody use the coordinates to figure this out? Okay, table 9 you guys did. So you guys, which coordinate did you guys use? B. So if you did B right here, right? B here was 3, 3, and B prime was 1, 1, right? So we had to divide to get to that by 3, which is the same as 1/3. Okay, either way works. Great. Okay, let's go. We're going to practice a little bit. Okay. Hopefully you can see this in the back of the room. I want you to determine what the scale factor is to go from the blue figure to the red figure. Okay, blue figure to the red figure. Okay, I'll give you about 30 seconds or so. So class, now normally I'll do this every now and then just to try to take you back to your elementary school days. I'll say class and kind of pause, and I want everybody to respond after that, like together. It's called choral response. Okay, so we're going to do that right now. So class, wait, whoa. Sorry, wait. I'll ask a question and then you'll respond. Okay, so class, is this a reduction or an enlargement? Okay, one or the other. So class, is this a reduction or an enlargement? Reduction. That word doesn't really come out very easily. Yeah, so reduction. Okay. Let's see, Javessa, what's the scale factor? The scale factor is 1/2. Okay. Well, I should have asked that different. I should have said that differently. Anyways, it is 1/2. Okay. Right, Javessa, how'd you figure out it was 1/2? Okay, so image to pre-image, it got smaller by 1/2. Okay, good. All right, let's do this real quick, and then we might be moving on from this in a moment. Okay, in fact, we're going to split it up a little bit. So table 1, 2, 3, 4, and 5. I want you guys to do number 1. Table 6, 7, 8, and 9. I want you guys to do number 2. Okay, all I want you to do is determine the scale factor. Okay, ready to go. All right, let's have your attention back here, please. Okay, class. Thank you. Okay, so tables 1 through 5, is this a reduction or an enlargement? Reduction, what's the scale factor? 1/3. Okay, table 6 through 9, is that a reduction or an enlargement? Enlargement, what's its scale factor? 3/2 or 1.5. Okay, good enough. Okay, all right, let's see. All right, we are going to, let's look at this one right here. Okay, it says, what are the coordinates of the vertices of this triangle after it's been dilated by 1/2? Now, part of the reason I want to bring this up is notation. Okay, if we use a capital D right here, we just mean dilation. The scale factor will always come after it, and it will kind of look like a subscript. Okay, so the capital D with the smaller 1/2 means that we're doing a dilation by 1/2 of whatever is in parentheses. Okay, if we did a capital D with a subscript 3, then we're doing a dilation by 3 of whatever's in the parentheses. So what I want you to do in your groups real quick, these points, so I'll just tell you what the points currently are. P is the point 2, negative 1. G is the point 0, negative 2. And Z is the point negative 2, 1. I want you to perform this dilation and then tell me what the new coordinates are. Okay? I'm going to give you about a minute or so to do that. Okay? Ready to go. Okay. All right. That should have been plenty of time. Let's talk about it. Let's see. Table 2. What did you guys come up with for the coordinates of P prime? P prime. Okay, 1 comma negative 0.5. Class, hey, let's have your attention, please. Do we agree with this for P prime, 1 comma negative 0.5? Okay, all right, table 4. What did you guys come up with for G prime? 0, negative 1. How many of us agree with that for G prime? 0, negative 1? Okay, I'm slightly concerned. 5 of you agree? Do we agree or not agree? Okay, so looking for hands here, right? It helps Tim if we're paying attention. Always good, right? Even when I'm giving you a hard time for not paying attention. Okay, so Z prime, table 8. That's you guys. Z prime, what do you guys have for the coordinates of Z prime? Negative 1 comma what? 1/2 or 0.5. Okay. Class, how many of us agree with that? Still less than half of us, or we just thought this too much? Too many calories being burned there, right, for some of us? Okay. All right. Okay. That's the idea here. Okay. So we're going to stop with dilation.